The topic of this paper deals with the formulation of a ductile damage evolution law suitable for proportional and non-proportional loading conditions. In the last few decades, a lot of work has been carried out in the continuum damage mechanics community in terms of experimental investigation and constitutive models for the description of the ductile failure phenomenon. In particular, recent works pointed out how the non-proportionality of the load affects the material ductility. Therefore, the aim of this paper is to develop the coupled elastoplastic and damage model with a new ductile damage law suitable for the description of proportional and non-proportional loading conditions. The details of the model are offered in the paper. The Moore-Coulomb criterion was selected for the description of the failure envelope in terms of equivalent strain to fracture. If the effect of the load angle and of the pressure on plasticity are neglected, the expression of the failure envelope can be simplified as a function of just 4 material parameters. However, the previous damage law is not suitable for the description of the ductile damage evolution under non-proportional loading path. To correct this drawback, an additional inelastic strain contribution, named the tangential plastic strain rate, is added to the ductile damage evolution law. The estimation of this new term can be found in a previous work of the author. Next, the model performances are tested reproducing the experiments carried out by Nishikawa and others in 1998. The slide introduced the geometry, the numerical assumption, and the 2 types of load, P and H, solicited in the structure. The elastoplastic parameters have been taken from the paper referenced in the slide, and the damage parameter were calibrated also with a uniaxial tensile test found in literature. As it can be seen, the new damage accumulation law can describe more accurately the structural response, with a better overlap between the experimental and numerical hysteresis loops. In conclusion, the paper showed that implementation of a coupled elastoplastic and damage model, suitable for the description of the damaging process under proportional and non-proportional loads. The new damage law allowed us to achieve a better description of the structural performances under non-proportional cyclic loadings.